All right, here we are ready to start our whole second set of information that we're collecting from the creek. We're looking at the chemical makeup of the water of Colgan Creek. We're taking water quality measurements. So you'll be using your next data sheet. It looks like this. We'll show you a picture up close of it. And each one of these 8 things we'll be testing the water for has its own set of equipment. And so as we go through these 8, we'll show you the pieces and parts of the test. We'll tell you what the results are so that you can keep along, follow along, and record along with us.
Today, we're going to do water quality measurements. You will need this data table and you will be filling out results 1 and 2 for our different water quality tests that are temperature, turbidity, phosphates, nitrates, dissolved oxygen, pH, available chlorine, and fecal coliform. Please have this data sheet out and ready throughout this video.
Okay, we're about to take our first 2 water quality measurements. Miss M is measuring temperature. She's got a thermometer, she's gonna put it all the way in the water, and she's gonna pick 2 different locations for her 2 thermometers. We've gotta wait a few minutes to get those results. In the meantime, Miss Brown is going to be measuring turbidity. How clear is the water? How well can we see through it? So she'll grab a sample of the creek water and we'll be peering through a tube to see how well we could see through it, and we'll take that measurement.
I'm gonna make sure to get water that's upstream of where I'm actually standing, so I don't get water that I've, what's the word, like mixed up, like made more turbid, less clear.
She's carefully getting the actual turbidity of the creek, not the turbidity of our feet in the creek. 25.
And this is us recording temperature. The thermometer is submerged in the water. We're gonna do this twice.
We can see Miss Brown, she's doing the turbidity test. She has her samples.
And then she's gonna put it right on this middle one. Now she's looking to see, can I see it as well as any?
Do you want to look down there?
Yeah, do that.
Can see pretty clear.
Is the black and white image as clear as it can possibly be? That would be a 0 reading on turbidity. There's no turbidity.
So this is our second turbidity test.
And I don't know, it looks pretty close to that. So again,
Let's have the students look through.
I don't know, 3 something? Less than 5, I think. It's even less than the last one.
All right, so we've come up with 2 measurements, a 5 JTU and a 3 JTU.
On our water quality data table, we're now going to record our data that we got for temperature, and we're going to collect the data for turbidity, which stands for Jackson Turbidity Units. For our temperature, our first result was 55 degrees Fahrenheit, and our second result was 54 degrees Fahrenheit. Please record this data. For turbidity, we had 3 JTU for our first result and 5 JTU for our second result. Pause this video and make sure that you record the data for temperature and turbidity.
Okay, so the next 2 water quality measurements we're going to take are about the nutrients that are in the creek, both phosphates and nitrates. We are going to have, Miss Brown is going to be testing for phosphates, and Miss M is going to test for nitrates, and
Then we'll read our results.
then let's do 2 at a time.
So Miss Brown's going to do 2 measurements, and right now she's collecting a fresh water sample of the creek and filling it up to 5 milliliters.
So we have 2 samples, and for phosphates, I got water into both of them at 5 milliliters of water, and now we're putting in this little
Reactant.
reactant, this little pill that's going to be the thing that tells us how much phosphates are in here.
All right, and I am so carefully placing these in here.
Okay, and then I'm gonna put the stopper on, and then there should be another stopper.
We'll want to make sure that that little tablet dissolves, and we're gonna wait how many minutes?
After the tablet dissolves, we're gonna wait 5 minutes to read the results.
Okay, so we'll set the timer.
Get those, shake them up until they dissolve.
Oh, so I'm shaking. I'm gonna
Shake
shake them right now.
first. Okay.
Oh, until they dissolve in then 5 minutes?
Correct.
Oh, okay.
Great. So we're gonna make those dissolve, and then in 5 minutes we'll check back in and read our results.
Here we are with the nitrate test. 2 test tubes filled up, and we will now add our first tablet to each one of these. We're just repeating the test twice. That's why we have 2 tubes. Miss M's gonna shake those up until they disintegrate. And then we're gonna add our second tablet. You can see it is a different test than the phosphate test, so it's different. These are tablets dissolved. Now I'm adding the second tablet to each one of these. It's
So-
actually a different tablet.
First tablet dissolved. Now we're adding the second one so that we can get our reaction.
We're gonna put those right in these little sleeves. We don't want the sunlight to get to it.
Once again, they're putting them in the sleeve so that the sunlight doesn't get to it.
Yes.
There we go. And Miss M's gonna continue doing her good job shaking it up.
And then we're gonna come back and check in how many minutes?
5 minutes.
5 minutes, and read our results.
So I'm thinking it's a 2. Would you guys agree?
I agree. It's not as light as a 1 and it's not as dark as a 4. So we have 2 parts per
Here's
million
the other one.
of phosphates, and our second result,
So I think the same. It's a 2,
parts per
right?
million.
Maybe
of
a
phosphate.
3.
It could be a 3. Yeah, I feel like it's in between 2 and 4, right?
Would you put the 2 samples next to each other to see, are we working with the same color? Or is one really?
I don't want to put it on the yellow because
Right.
it changes it when you put it on. So I think
Yeah, one
this
is
one
a little
is a little darker.
Oh, cool. Okay, so a
you got it.
2 and a 3.
And that is our phosphate reading.
Ready to check. All right, let's check our. Okay. I don't know how to use
We're
it.
checking our nitrates,
Yes, let's do it. Where?
taking them out of the sleeve that we placed them in.
There is one. Here is the other. And let's check them out. So nitrate. I don't know. What do you think? A 0? I mean a 5? 0?
Say like maybe a 2.5.
Yeah.
Yeah.
I see the beginnings of some pink color coming in.
And then here we go with this other one.
And that one looks a little bit darker.
Closer to a 5, maybe like a 3.
Yeah, I would say we maybe have about a 2 and a 3, or a 2.5 and a 3.5.
Yeah, I agree with that.
All right, and that's our nitrate. Let's record it.
On our water quality data table, we're now going to record data for phosphates and for nitrates. For phosphates, we got 2 parts per million for our first test and 3 parts per million for our second test. For nitrates, we got 2 parts per million for our first test and 3 parts per million for our second test. Please pause this video and record the data.
All right, we are taking a dissolved oxygen reading, and that happens in these glass tubes. You see Miss M's filled these up to overflowing because we don't want to cap any of the air inside the creek water because we get a false reading. I use my bag to protect my work here.
We just took that water sample directly from the creek section that we're in.
And these get 2 tablets. These are all different tablets. These are all different reactants asking the water to tell us, in this case, how much oxygen is dissolved in it. And so after I put these 2 tablets in, we then cap them off and then shake it until it disintegrates.
Do you see how it's overflowing? Overflowing.
There we go. That's a clear image.
Great. And then we have to disintegrate these, and then we start our timer.
Some more shaking.
So you want them more shaking.
And this one might be like a 6.
Okay, let's do that. All right, we've got our dissolved oxygen results back. We have 2 different results from our 2 different samples.
So this one is closer to an 8, so we're gonna think maybe like a 7. And this one is kind of like between a 4 and an 8, but maybe closer to the 4, so maybe like a 6.
So 6 parts per million and 7 parts per million.
We are now going to record our data for dissolved oxygen in parts per million. For our first result, we have 7 ppm, and for our second result, we have 8 ppm. So 8 parts per million and 7 parts per million. Please pause this video and record your data.
We are continuing our tests. We are now looking at the pH of the creek water. We will add a pH reactant to each one of our 2 samples. And this one we mix and test right away. No waiting.
So we're just going to wait for that to dissolve, and then we're going to read our results on this card, and it's going to tell us what the pH is. We're going to see if we're more on the basic side, neutral, or acidic.
Okay, I think that is. Oh, not quite. Almost. Yeah, there it is. Okay. Yep, they're dissolved. So, what color are we closest to? Is it that one?
Or this one.
Or that one? I can't quite see from where I am.
And
Maybe
I
a
wonder-
7.5.
And I wonder if students
All right,
know
let's.
what number is the magic number.
I think it's 8. Oh, sorry. I think it's 8.
I do too.
And then.
Because it really doesn't have any spring green
No,
quality to it.
I think it's definitely 8. And then this one, same.
Oh yeah.
Yeah, 8. Yeah, I don't, or 7. It's a little closer to 7, I
But
think.
it's not a total 7.
No,
So
it's
maybe like
7.5. That one might be 7.5. Are they the same?
I think they're the same.
Okay, so 8.
Yeah,
then?
I do.
For both of them are
I
8.
do, yeah.
Okay.
So we're going to go with 8 for both of our tests for pH.
We are now going to record our data for pH. pH ranges from 0 to 14. For results 1 and 2, we have 8 for their pH. Once again, 8 for our pH for both tests. Please pause this video and record your data.
All right, the next test we're doing is to test to see if there's any chlorine in the creek. So we've got our 2 samples. We'll add 1 reactant to each one of these samples. As soon as it's dissolved, we'll take a reading to see if there's any chlorine in the creek.
Miss M is shaking that up.
And you can see if she gets any pink color, any gradient of pink color indicates that there's chlorine in the creek. So we'll put that in there, take a look and see what you think. Is there any pink in the sample? Or does the sample more match a no pink?
We're going to go with no pink.
No pink.
So that equals no chlorine in this creek, which of course we are thrilled about.
Yay, so that's a good thing.
That's a great thing because chlorine has the power to kill pretty much anything it comes in contact with, and we want this creek full of life. Second sample,
No chlorine.
2 zeros for chlorine. Great reading.
For our next test, we have available chlorine. We're going to record those results. We had 0 parts per million for both tests. Again, 0 parts per million for both tests. Please pause this video and record your data.
Okay, the last test we're going to do today is to see if there's fecal coliform bacteria present in Colgan Creek. We will fill up this vial with Colgan Creek water. Inside the vial is a sugar pill, and if there's fecal coliform in there, the sugar pill will feed that bacteria. The bacteria will eat it and grow in number, and in 48 hours, we'll take the result. We'll look to see, yes, there's fecal coliform, or no, there's not fecal coliform.
So we're setting up this test, and then we're going to do our positive and negative reading in 2 days?
In 2 days.
In 2 days. And Miss Brown's shaking those up. That's our test tube, and we're going to come back and visit that.
Can you see the red dye that's in there? If there's no bacteria, they won't eat. They won't eat the red dye. So at the end, if there's no bacteria, it is negative. It stays red.
We are now going to record our data for fecal coliform. So we had to wait 2 days to read that data, and if it was pink, it was negative, and if it was yellow, it was positive. What do you think it was? Well, both samples ended up being yellow. So if you look at your measurement, we're going to write either a P for present or an A for absent. Since the test was yellow, it was positive, which means that fecal matter was present. So we'll do a P for result 1 and a P for result 2. Pause this video and record your data. Good job, everyone. Don't forget to record all of your data for water quality and submit all of your assignments on time. Good job and take care.